According to the National Electrical Code, specifically Section 250.122c, the grounding conductor for a center pivot sprinkler head must be sized at 125% of the motor's full load current, also referred to as FLC. This requirement is in place to ensure adequate grounding protection for the equipment and to minimize the risk of electrical shock. Understanding the full load current is crucial for proper sizing. The full load current refers to the current drawn by the motor when it's operating at its rated horsepower and voltage under full load conditions. This value can typically be found on the motor's nameplate. To determine the minimum size of the grounding conductor, you must first identify the full load current of the motor that powers the center pivot irrigation system. Once you have the FLC value, multiply it by 1.25 or 125%. This resulting value will be the minimum amperage the grounding conductor needs to be rated for. Next, refer to NEC Table 250.122 to find the appropriate grounding conductor size based on the calculated amperage. Table 250.122 provides the minimum size of equipment grounding conductors for grounding raceway and equipment. It correlates the rating of the overcurrent protective device in the circuit to the required size of the grounding conductor. When selecting the conductor, ensure that it is properly insulated and suitable for the environmental conditions in which it will be installed. Factors like moisture, temperature, and exposure to chemicals should be considered. Also, ensure that the grounding conductor is connected to a grounding electrode system that meets the requirements of NEC Article 250. This typically involves connecting to a ground rod, ground ring, or other approved grounding electrode. Proper installation and connection of the grounding conductor are critical for its effectiveness. The conductor should be securely connected to both the sprinkler head's ground ring and the grounding electrode system. The connection should be made using approved connectors and methods to ensure a low impedance path to ground. Regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. Check for any signs of corrosion, damage, or loose connections, and address any issues promptly. It is also important to note that other sections of the NEC may also apply to the grounding of center pivot irrigation systems, depending on the specific installation and equipment. Consult the NEC for the most up-to-date requirements and seek guidance from a qualified electrical professional if you have any questions or concerns. The grounding conductor ensures a safe path for fault current to return to the source, which facilitates the quick operation of the overcurrent protective device, such as a circuit breaker or fuse. This rapid response helps to prevent electrical shock hazards and minimize damage to equipment. It is important to use properly sized grounding conductors. An undersized grounding conductor may not be able to safely carry the fault current, potentially leading to overheating, insulation damage, and even fire. An oversized conductor, while not necessarily unsafe, can be more expensive and may not provide any additional benefit in terms of safety or performance. Grounding is a critical safety measure that protects people and equipment from electrical hazards. By following the requirements of NEC Section 250.122c and ensuring proper installation and maintenance, you can create a safe and reliable electrical system for center pivot sprinkler systems. It is important to remember that the NEC is a comprehensive set of electrical safety standards, and it is essential to consult the latest edition for the most accurate and up-to-date information. In addition to NEC Section 250.122c, other sections of the code may also be relevant to the grounding of center pivot irrigation systems. These sections may address topics such as grounding electrode systems, bonding, and overcurrent protection. It is important to review all applicable sections of the NEC to ensure compliance with all requirements. Also, it is essential to consider any local amendments or interpretations of the NEC that may be in effect in your jurisdiction. Local authorities may have additional requirements or interpretations that must be followed. Working with a qualified electrical professional is highly recommended. A qualified electrician can assess the specific installation, determine the correct grounding conductor size, and ensure that the system is installed in accordance with all applicable codes and standards. It is also important to maintain accurate records of the grounding system, including the size and type of grounding conductors, the location of grounding electrodes, and any test results. These records can be helpful for future inspections and maintenance. Proper grounding practices are essential for the safe and reliable operation of center pivot irrigation systems. By following the requirements of the NEC and working with qualified professionals, you can minimize the risk of electrical hazards and ensure the longevity of your equipment. When sizing the grounding conductor, it's important to consider the ampacity of the conductors that supply the motor. The grounding conductor must be sized no smaller than what is specified in Table 250.122 based on the size of the overcurrent protection device protecting the circuit. In many cases, the full load current of the motor will be used to determine the size of the branch circuit conductors and the overcurrent protection. However, it's important to ensure that the grounding conductor is sized appropriately for the actual overcurrent protection used. If the overcurrent protection is sized higher than the full load current of the motor, the grounding conductor must be sized accordingly. Keep in mind that the NEC provides minimum requirements for grounding conductor size. In some cases, it may be necessary or desirable to use a larger grounding conductor than what is required by the code. This may be done to reduce impedance, improve fault current carrying capacity, or provide additional mechanical strength. The type of grounding conductor used is also important. Grounding conductors can be either copper or aluminum. Copper is generally preferred due to its lower resistance and higher corrosion resistance. However, aluminum conductors can be used if they are properly sized and installed. When using aluminum grounding conductors, it's important to ensure that they are compatible with the connecting hardware and that they are protected from corrosion. All connections must be made using listed and labeled connectors and fittings. These connectors are designed to provide a reliable, low-impedance connection between the grounding conductor and the equipment or grounding electrode. The connectors must be properly sized for the conductor and must be installed according to the manufacturer's instructions. It is critical to ensure that all grounding connections are tight and secure. Loose connections can increase resistance, reduce fault current carrying capacity, and create a potential fire hazard. Grounding connections should be inspected regularly and tightened as needed. In addition to the equipment grounding conductor, a grounding electrode conductor is also required to connect the equipment grounding system to the grounding electrode. The grounding electrode conductor must be sized according to NEC section 250.66. The size of the grounding electrode conductor depends on the size of the service entrance conductors. The grounding electrode conductor must be connected to a grounding electrode that meets the requirements of NEC section 250.52. Common grounding electrodes include ground rods, ground plates, and metal underground water pipes. The grounding electrode must be installed in accordance with the NEC and must be properly connected to the grounding electrode conductor. Regular testing of the grounding system is recommended to ensure its effectiveness. Ground impedance testing can be used to measure the resistance of the grounding system. A low impedance grounding system is essential for providing a safe path for fault current. If the grounding impedance is too high, it may be necessary to improve the grounding system by adding additional grounding electrodes or improving the connections. It is very important to understand the difference between grounding and bonding. Grounding is the connection of the electrical system to the earth. Bonding is the connection of all metal parts of the electrical system together to create a low impedance path for fault current. Bonding is just as important as grounding for electrical safety. All metal parts of the electrical system, including enclosures, raceways, and equipment, must be properly bonded together. Bonding is typically accomplished by using bonding jumpers or bonding conductors. Bonding jumpers are short lengths of conductor that are used to connect metal parts together. Bonding conductors are used to connect metal parts back to the main grounding bus bar. All bonding connections must be tight and secure. Loose bonding connections can increase resistance, reduce fault current carrying capacity, and create a potential fire hazard. Remember to follow the manufacturer's instructions for installation and maintenance of all electrical equipment. A proper installation or maintenance can create a safety hazard.